So let's see here. So Yush and I are going to be talking a little bit about YOLOv5, and we're going to explain some of the steps that we've done here and why we say that we're sort of redefining the state of the art. So the idea is that we've built a lot of improvements into YOLOv5. A lot of the custom ones are, I guess, the traditional ones that people really talk about, which are things like architecture improvements. And then some of the ones that people don't often talk about. And these are things like usability, like how easy it is to get started, how easy it is to train. And this is stuff that's sort of not discussed often, say in research publications or even in repositories. But when we arrived at the scene, we realized that there's a big disconnect between laboratory results and real world results. So we started in particle physics, and we were literally in the laboratory. We had different particle physics detectors. We would collect data, we would train models, and we would apply those models on the detectors. So in our domain, we did not have real world data. So we simulated data, and our results looked really good. So then when we turned around and applied those to our real world results, everything fell apart. And we rapidly discovered something that a lot of companies discover when they're putting AI solutions into production. And this is simply that what you see when you're developing is not the same as what you see when you're deploying. So we've got a couple slides here. Let me share my screen. Let's see. Okay, share screen. Okay, Google Chrome, share. Hold on. I did not do that right. Let me try that again. Okay. So with YOLOv5, our main vision really has been to bring simplicity to AI. So AI has got a lot of potential, and we believe that the potential is still locked up in the technology. We need to make it easier to use. We need to improve results so that we can expand use cases. And to do that, we need to expand the market. So we need more people using AI tools. And this is these are all parallel tracks that feed into one another and can't really happen in isolation. So a lot of people ask us, what makes YOLOv5 such a good tool? Why is it so successful? Why do people like it so much? And of course, there's no single answer to this question. There's no silver bullet. The truth is that there's 1,000 small improvements built in into innumerable places in the code. These are things like data loading, augmentation, loss functions, architecture, and simply like UX for ML ops. And this is things like making commands simple, adjusting settings automatically based on data sets. And this is something that is really key, I think, to real world results. So it's sort of like that missing puzzle piece that lets you translate those laboratory results and those publication results into something that a company can use in a product or simply a researcher right there, out there in the real world.
Glenn, so, I think so just to add to that, I think one of the things that I really wanted to add was that, I mean, your focus has not been about one architecture, one model, or one metric. Like, it's just one of the themes of today's all of these talks is that we are trying to make sure that the users get the most seamless experience in training cutting edge AI models end to end. Like, it's not about one particular model, one particular metric. It's the entire experience, right?
Absolutely. Yeah, with this is a chain, and if there's a weak link in the chain, then it fails. And so if you have a really powerful architecture, but you have no data to train it on, or a very poor data set, you're going to get poor results, vice versa. And if you lack deployment tools, like let's say you train an amazing PyTorch model and you want to deploy that to an iOS app, if there's no export functionality or certain layers aren't supported, if you can't get that link in the chain completed, then the whole effort's been for nothing. And so we've worried about every link in the chain. We've worried about how the users come into the ecosystem, pointing them to the right places they can get the data, integrating with companies that are really great at data set tools like Roboflow, for example. And of course, our specialty is training, But then after the training is complete, also helping them get that model into the format that they need, helping them preview it with our iOS and Android apps, and helping them deploy it with API examples, with like REST examples for APIs that they can use with Google Cloud, Amazon Cloud, and others.
Yep.
I think bringing a lot of these under one roof is also kind of important. So in the AI world, there's a lot of tools, right? And there's a lot of companies that really specialize in different places in the verticals. And a developer will need to create multiple accounts, familiarize themselves with different tools, set up billing information. And that's really complicated. So to the extent that we can, we've tried to bake a lot of this into YOLOv5 directly. And where we couldn't do that, we've tried to search the market for partners that were really good at these things. So for example, on the dataset side, we worked with Roboflow. They're very popular with the community, and they have a tool for uploading open source datasets, and they can export directly to YOLOv5 format. So if you have a data set there, you can annotate it, you can export it to YOLOv5 format, and you can start training on it right away. Mm-hmm. So this is part of the different environments that we set up for training. Is we have a bunch of options, and so we think that there's no right answer. The users are usually right in what their preferences are, and so if people are familiar with one tool, they're probably going to want to use it. And so we've gone to great efforts to show examples and quick start tutorials for environments. And now we have a wide variety. So some of the most popular that we see here are Colab notebooks, Kaggle notebooks, Paperspace, Gradient notebooks, and also Docker images and cloud VMs like AWS, AMIs, and GCP VMs. So we've used all of these, and we have quick start tutorials for people to get started with them right away. So if you're not familiar with them, you can just click any of these icons on a repository. You'll see like a nice easy tutorial. And of course, we are very responsive. So if you have questions, you can simply ask them, and we get back to you right away. Yeah. So besides setting up an environment minimally, setting up hyperparameters is kind of scary, right? So training a model requires a lot of settings, and it's not always obvious what these settings should be. So I just came into AI recently. So 3 years ago is when I started working with machine learning models, simple regression models for particle physics at first, and now YOLOv5. But to be honest, like nobody really has a complete intuition of what certain values should be. So if you look at hyperparameters like a learning rate for an optimizer, or maybe an image size or anchor values for object detection models, you can talk to the smartest people in the world, and they'll probably tell you that you need to run some experiments to see what the best values here are. And so we've done that on some of the most common data sets, and we've come up with a baseline set of hyperparameters that work best on data sets like COCO, VOC, Objects 365. And we provided these for you also for different model sizes. So small models, they'll tend to not overtrain as much as large models. So they learn a little more slowly, and they take a little more epochs to learn, whereas large models will learn faster. But that also means that if you train them with the same settings, they'll start overfitting earlier. And so there's no one size fits all solution here. But we've tried as much as we can to sort of like semi-automate the process of training so that when you load up different models, like the correct hyperparameters for that model and that data set get imported.
Yeah, Ken, I think one of the reasons that we should highlight here that YOLOv5 is really easy to set up is because it was the first implementation of YOLO algorithm that actually was done totally in Python from scratch, right? So it has no dependencies on any other languages. So you can simply set it up on any of these like mentioned environments within seconds, which is like the testament to its simplicity, right?
Yeah, I remember when I first came in, YOLOv3 was in Darknet by Joseph Redman. He did an amazing work there, but Darknet was written in C. And while it's an impressive piece of work, C is not the easiest language to learn for newcomers these days. And it was poorly documented. And so there were some frameworks that were out that were better supported, maintained, and documented, and written in Python. So PyTorch seemed an obvious choice when I started working on YOLO models. And of course, I think my main contribution at first was the Ultralytics YOLOv5 repository, which was a translation of darknet, or at least the modeling components, into PyTorch and running experiments to reproduce the same results. I think there have been a few efforts up to that point in time, and none of them were reproducing the darknet results. And so it took me a long time. Since I was new to AI, I was also new to open source. It took me the better part of a year to build the YOLOv5 Python repository. At first, I could get good inference results that arrived pretty quickly. I might have done that in a month or two, but training was much harder. And that took me the rest of the year. So, and this is where I started learning all my lessons. So the best way to learn something is to try it, I think. And I did a lot of trying, a lot of failing that year. And that's an integral part of the journey that got us here to YOLOv5, which bakes in, of course, all the lessons learned there. And of course, all the community contributions from the hundreds of people that have given back to YOLOv5 to improve the code, to add features, or fix bugs that pop up.
Yep.
Okay. So there's a few different ways that you can use YOLO here. We can use what's called the CLI, and this is the command line interface. So if you use Linux, you're probably pretty familiar with this. So you can run a command. We see an example here, python detect.py, and you can point this to a source. So the source can be images, a single image, a single video, or a directory full of images and videos, or many other things. So you can point this directly to a YouTube video, for example. So we've got all the details on the repository, but the end result is that it's super simple to try out YOLO. So you just run this command and point it anywhere you want, even your webcam, it'll start running right away. If you don't have models locally, it'll download them for you. And this will really get you up to speed quickly in just a single line. So the second one is PyTorch Hub. So the CLI method is really good for demos. And this was my original intention. It was just for people to demo YOLOv5 and then go on and write some of their custom code. And PyTorch Hub is a way for people to do this. It's in Python. So you can load a model into a Python environment. That's what we see right here. We're loading a YOLOv5s for small model. And then once it's in the environment, it is ready for inference. So you can pass it an image and it will return you the results. And the results it's a class, it's an object. So results instances contain lots of information and have lots of methods. So they're pretty smart. You can print them, you can save the results, which will save images with annotations. You can show the results to see the results live in your workspace. And you can also get the actual predictions as different types of objects like NumPy arrays, pandas, datasets. And if you do go to pandas, then you can export that almost anywhere. Things like Excel spreadsheets, JSON files, text files, CSVs. So there's incredible flexibility here. And between these two methods, I think the first one really provides you the most simple way just to get some results, to see what the model is doing. And then once you want to create a more of a custom product and embed YOLOv5 into your product, then I think PyTorch Hub is the simplest way to load it and the simplest way to run inference in a Python environment for it. So the last one that we see here is arguments. And so hyperparameters, data, and lots of other arguments like image size, optimizers. These are available directly from the CLI. So when you train a model, you can really customize it fully. So some of these are also automatically adjusted based on your data set. And so this is, I think, one of the key breakthroughs with YOLOv5. For example, if you have a data set with, say, 10 classes, then we adjust classification loss hyperparameters based on the number of classes, which is something that, like, before I came along, wasn't immediately obvious. Like, so people would get different results on different data sets, and sometimes results you saw in a paper didn't correlate really well with the results that you saw. And so there's a lot of small changes everywhere in the repository to try and help people get good results the first time. And of course, you're never going to get the best results the very first time if you tune your hyperparameters or evolve them, which we also make very easy. Then this is another route to improving your results automatically, given sufficient resources. Okay. So one of the things also that we noticed when we came in was that all the repositories out there made export very painful or didn't support it at all. And this is the approach that we took when we arrived, honestly, at the beginning too. So at first I was just fully focused on YOLO, and users would ask a question. They'd say, where can I find data to train my model? And I would think about it. I'd say, oh, data? That's not, no, we don't do data. We just do training. So just go find the data yourself and come back. And then they'd say, okay, they'd find the data, they come back and they train it successfully. And they say, hey, Glenn, I trained my model. I got these really great results. Like I want to deploy it to like an Android app. What do I do? To deploy it. I say, oh no, we don't do that either. But just go figure that out on your own. And then I started realizing it's not conducive to helping people. And so now we really help people before they arrive at training and after they're done with training. And after they're done, of course, you're going to want to export this to a different format. If you're going to be deploying this to a CPU, then you're probably going to want an OpenVINO or an Onyx format, and you're probably going to want to quantize it. And we help you do that with export.py. We make it very easy. Now you can export not just detection models, but also classification models and the new YOLOv5 segmentation models that we have. So besides, oh, I forgot the other option. So when you're deploying to a GPU, TensorRT is going to be your fastest option. And again, we make that very simple. If you don't have TensorRT installed on your system, we'll automatically install it for you, export that. And after you're done exporting, the natural question arises, how is my exported model going to perform, right? Have I lost any accuracy? Is it faster? Is it slower? What's going on? And so all of these exported models can be used directly with detect.py and val.py and PyTorch Hub. So this gives you really great confidence that your exported model is producing the same results as your PyTorch model. And again, this is something that's completely absent, I think, from most frameworks and repositories. So like not only do they really not help you export, but then once you've exported, they really don't help you verify and validate that your model is producing the same results, so you haven't lost something in translation there.
Mm-hmm. Yeah, I think it's really important to, it's a guarantee that whenever you train a YOLOv5 model, you will be able to export it to any of these platforms, right? And we have made these R&D decisions also that we won't include any of the architecture changes that break these exports. So whenever someone trains a model, they only have to care about the business applications or their project that they're solving. It's not about like whether I'll be able to deploy it in a particular device, whether it's a smartphone or a TensorRT based device or something like that, right?
Yeah, that's right, Yush. So we really had a debate a couple of months ago. We found this new module which seemed to perform a little better in accuracy, but it wasn't export friendly. It was a little complicated and not all the formats supported it. And so we decided not to include it in architecture changes because it would have broken export workflows. So like Yush is hitting on a good point though. That I think to kind of invest in this process is a big hurdle, right? For a company to come in and say, we're going to dedicate the resources to collecting the data, training this model, exporting it, and just hoping for the best. That's a difficult decision to make. And with YOLOv5, you can have great confidence that whatever model you train is going to be fully exportable and performant on all these end destinations. And what we're seeing right here is a variety of TensorFlow destinations. We also have CoreML for iOS apps, OpenVINO and Onyx for CPU deployments, TensorRT for GPU deployments, TorchScript, which is runnable on C and C++. We have Edge TPU also formats for running on Google Edge TPUs. And lastly, there's one that's not shown here, which is Paddle, which we recently introduced. So I think among all of these, there's probably the format that you're interested in. If there's anything missing, obviously let us know. And if it's a popular feature, we'll add it. We have a lot of feature requests and we kind of rank them by priority, but the ones that get more commonly requested, we bump up. So, okay, so we've talked about certain elements of training, deploying, and this is how they relate to each other. So this is the iterative nature of ML is incredibly important. So if we wake up in the morning and make a mistake, the chances are we won't make it the next day, right? But if you think about an ML model that's deployed, if it makes a mistake on Monday, it'll make it on Tuesday and also on Wednesday, and it'll keep doing it. So to have ML models behave more like human beings, like ourselves, and learn over time to compensate for, say, domain drift or simply to learn, to evolve, we have this cycle. And so AI is really not an open-ended system where you collect data, train, deploy, and then go on vacation. It's an iterative loop, which in reality never finishes. So what we have here is the three main elements. We have data set collection and annotation. And then the second one, we have training a model. And then the third one is deployment. And they're all important and they go in this order. And once you're deployed, the arrow here connects back to data sets, because what you want to do is you're going to find places that your model is not performing well. So no model is going to be 100% accurate all the time, just like a person is not. But you can find those images that it fails on. You can find those images that it has low confidence on. And you can do this in a few creative ways automatically. And once you have these edge cases that you've collected, you can re-annotate those. And this can be a manual process. It can be fully automated, or it can be semi-automated with human supervision. But the data set will be augmented. It'll be improved and increased, especially in the areas that the model's weak in. And then you simply rinse and repeat. You train your model, redeploy to the same place, and start again. So in this way, the model will not drift over time. It'll stay current with domain changes. So for example, if you train a people detector in the summer, and then suddenly people start putting on long pants and jackets in the winter, the model may have lower confidence in those people, or may simply fail to see them. And so this is a way that your model will stay updated and remain pertinent. And so this is something that we've tried to facilitate a lot with YOLOv5 and with our upcoming Ultralytics Hub. We don't have fully closed solutions for this yet, but this is the direction that we're taking. And this is really front and center in our product roadmap, is to be able to offer solutions to close this loop and to allow people to deploy, monitor, collect edge cases, augment their data set with those, and retrain and redeploy. I think that's super important. What do you think, Yush?
Yep, I think so. This also fits into our initial mission to make every step of the way really easy. So like when you talk about data sets and deployment, these are pre-processing and post-processing of a model, right? So essentially what we can provide with the users with is the seamless experience to train these models. But at some point they have to leave the repository and venture outside and find things manually. So we are also committed to have their backs on every step of the way. Like for example, starting with data sets, with Roboflow integration, you can just click on like with one click, you can just export the right format of the data set and start training with just one single command, right? That's simplifies the process. Whether you're training as an individual or working with a team of practitioners, you can collaborate better, manage your experiments and resources better with all our experiment tracking tools. And recently we've been partnering with Paperspace to provide easy setup for the GPU platform. And then it's also about the deployment side, right? We have seen exports, but then that's not the end of the story. You can also sort of optimize a model based on a particular hardware. And so like our deployment partner, Desi, does all of that. And it also supports YOLOv5 out of the box, right? So it's like whenever you see YOLOv5, you can rest assured that it is going to be a simple process, whether it's through the repo or outside the repository. And we are committed to making those partnerships with the industry leading tools for the users, right?
Yeah, absolutely. So we're not just creating a great architecture, but we're creating the ecosystem around it that's necessary for it to thrive. The examples for people to use it, the integrations with other tools to be able to really quickly start training from data, to deploy to many other platforms. And I think this is really the right way forward. I think an all of the above approach is correct. So I think one time somebody asked Obama what the right solution is for climate change, and there's a variety of different things we could do, and he said all of the above. And I think in AI, I think we have to take the same approach. I think it's not sufficient to just be super performant in one vertical. Even if we have the best training architecture, people are still going to need help training on those models and deploying those models. And I think realizing all the steps that are necessary and helping people do those is really the right way forward.
Great. Yeah, we have some questions also. So I think we should start taking them because we have very less time remaining. So
okay.
Pedro asked, curious to know what to expect from the release 7 at the end of this year.
Yeah, this is a good question. So the landscape in AI is really interesting these days, especially the YOLO landscape. A lot of companies are getting interested, and big names like Meituan are jumping in, Baidu, with paddle. And so we need to navigate these waters and figure out the next steps. So I won't say too much here, but I will say that we have some really exciting updates coming in the next few months. And stay tuned because this is really going to be amazing. We've been working on this behind the scenes, and I think that what we're about to release here in about 2 months or so, I think is going to be pretty incredible. We're putting a lot of work into it, and we are folding in a lot of lessons learned from the past. So what we have right now is it's about to get better. It's about to get a lot better and even easier to use.
Yep. Stay tuned and stay hyped. So next question is from Yosias from Indonesia. And so he says, I'd like to ask, can YOLOv5 be used for structural health monitoring, especially like detecting severity of rust and cracks that occur on metal surfaces?
Yeah, definitely. There's a lot of use cases for flaw detection and also for damage detection. So there's some companies that are using YOLOv5 for, say, automated examination of rental vehicles. So you return them and it'll spot like dents and scrapes on the vehicles and on the manufacturer line also. So we have some very large companies that are doing a lot of manufacturing, and every once in a while they'll have a flawed product and they'll throw it away. And YOLOv5 is really good at spotting those. So I think this could definitely be a suitable use case. I think anything, what I typically say is, for people that ask us about possible use cases, the rule of thumb here is that if a relatively smart person can do it, not even really, like if you and I can do it, like if you can spot these cracks, and then it typically means that like the YOLO model will also be able to be trained on those and spot those cracks. I think what's important is to keep in mind that the model will never be 100% accurate. It might be like 99%, 95, 90. So you need to build in this knowledge a priori into your product or into your workflow. And by what I mean by that is, like you need to build your workflow to expect occasional failures. And so like a way to do this might be to train 2 models and have them check each other, or maybe you prioritize false positives to increase recall, and then you just have a person filter those false positives. But I think it definitely detection of flaws, structural health monitoring is definitely kind of a mainstream use case for YOLO. Mm-hmm.
Great.
Okay.
I think we don't have any other questions, so I think we should wrap this up.
Sounds good.
Oh, okay, we just got one. Hold on.
We got a long one. Let's see.
Okay, it's a big one. You like to take it part by part?
It's got 3 parts. Maybe let's see. It says, hello, Glenn and Yush. I'm quite new to AI deep learning and I have a few questions. Okay, so what are references, books, repos would you recommend to someone trying to understand the science behind vision AI? Would you ever consider implementing a multi-frame object detection? And in addition, would you ever release how data scientists collect data and labels? Well, actually, number 3 is really interesting. So the data collection is a bottleneck typically in a lot of workflows. And so some companies get really creative, not just in collecting data, but in labeling. So the CAPTCHAs that you see sometimes to like verify that you're a human being, you're actually helping label data. So when you click and it says like, tell me the squares that are crosswalks, and you click them, then it's taking that information. Google's collecting that. They're putting that as human annotations on a data set, and they're training classification models with those. So some companies get very creative. Tesla, with their autopilot system, they had an auto lane change feature. And when the AI decided it wanted to change lanes, the human would have to confirm it. And so this way they were collecting like a yes or no from the person. So they're collecting actual human annotations. And annotations are always more difficult than actually collecting the data itself. Data let me give you like a third example. If you want to collect, in my previous example, we talked about the iterative nature. You want to collect cases where your model's underperforming, and you can do this simply by collecting images where it has low confidence. So typically, if your model's identifying people with 90% confidence, and in one image, you see an image and the person's been identified with 30% confidence, that's a red flag. And so you can just save that image, and you can put that back into the data set. You can have a person annotate that and put it into your data set to improve it. About your other two questions, number one's a bit difficult. So I didn't go to school myself for AI. I was self-taught, but I started from examples. I work best from examples. And so I went to PyTorch, which had really great tutorials. And of course, just around the community. Once you start using a tool, you go to the questions, you read the issues, you'll start to see people talking about other repositories, other frameworks, and you get a bit of a sense of like what the community is interested in, where the attention is. So I think just really kind of like seeing like social media and where the buzz is.
I also think there's a lot of classics, right? Like for example, I personally always go back to Karpathy's CS221N. That's one of the best courses ever. It builds up the foundation for computer vision and everything. But then to stay up to date, definitely you cannot stick to one particular tutorial or one particular course, right? You have to always look out for the new articles, new community, as Glenn mentioned. But yeah, some classics ones are really great. And Karpathy's new course on language modeling is also like currently under development. So he's releasing new stuff. So that I probably follow like the experts, but then also follow like some of the communities that are currently working. So that would be my strategy. But then everything, like learning is different for everyone. So like you can experiment there as well.
That's true. That's true. There's definitely a lot of academic courses, but you're right. Whatever you learn there, by the time you're done with the course, it might already be outdated. It's a rapidly changing field. In the panel before, when Paddle said that they just released paddle detection in 2019, it really struck me. So just in the last 2 or 3 years, so much has changed in the landscape.
Yep.
And let's see about this last question. Would we consider implementing kind of like video tracking, or at least like multi-frame models? So this could definitely be implemented. You could consider a 3-channel input that we have right now, like an RGB image. You can expand that, say, to 12, and then you could pass in 4 consecutive video frames, and then maybe spot differences between them, or leverage those in a way that you can with a static image model. So we haven't put a lot of effort into video annotation and training in particular, even though there's specific applications for it that use memory, like short-term memory, because it's simply a bit of a smaller market, and the applicability, for example, on the image side, wouldn't be there. So if you train this type of model, then you'd have to feed it just a video. So we tried to find like the biggest addressable pain points, like for the community, and object detection seems to be that. It's kind of like front and center in the vision space. So we put all our effort into that. Though we are branching out. We just released classification, and we're experimenting with segmentation too. So
great. Yeah, I think we're already over by 5 minutes. So if you have any other questions, just go on GitHub/Ultralytics/YOLOv5, and Glenn answers all those questions every day. So yeah, if you have any other questions,
also
there. And so yeah, let's wrap this up, Glenn.
Great. All right, sounds good. Thanks for listening in, everybody. Bye.
Awesome. Bye.